Hi everyone. In the previous section, we saw how English statements are represented by propositions, how logic works through connectives, and we discussed some important mathematical theorems. In this final section of propositional logic, we will talk about logical properties like tautologies and contradictions, and some basic rules which are embedded in logic. Let us start by seeing what a tautology is. Tautology is a formula or assertion that is true in every possible interpretation. Or in other words, a tautology is a statement which has the truth value true irrespective of the truth values of its component statements. For example, taking the case of the statement P or negation of P. This proposition could be understood by mapping the truth table of its constituents and then applying the OR operation. P or negation of P shows all values as true, and thus we can say that P or negation of P is a tautology. Let us consider some more examples. Considering the statement P implies Q is equivalent to negation of Q implies negation of P. We all saw the contrapositive law in the last section. It said P implies Q is contrapositive to negation of Q implies negation of P and vice versa. What it means is that they hold the same truth values and this statement should ideally be a tautology. To check if that is the case, we start by drawing a truth table. From P and Q values, we can calculate the values of their negations. Now we perform the implication on P being the hypothesis and Q being the conclusion. We know only in the case where a hypothesis is true and the conclusion is false, we say that the implication results into false. In all other cases, it results into true. By the same principles, we can calculate the negation of Q implies negation of P. But here the hypothesis is negation of Q and the conclusion is negation of P. Which means in the case where Q is false and P is true, the implication results into false. Otherwise, true for all other cases. Both these statements are separated by an equivalent operator, which checks if they hold the same truth values. Now, we can say that P implies Q is equivalent to negation of Q implies negation of P is a tautology because all of the values are coming to be true. Let us see another example. Whole negation of P implies Q is equivalent to P and negation of Q. We will perform the same steps as before to calculate the truth values by solving for each component statement step by step. So in this case, let us start by flipping Q bits to get the negation of Q values. Now we calculate P implies Q as we did in the last example. Now, applying the AND operation between the negation of Q values and the P values. For AND, we know that whenever both the values are true, it results in true. Otherwise, false. Now we compare the negated of the calculated P implies Q value with the values for P and negation of Q. We can see that again we get all the values as true, which means this also is a tautology. Let's discuss the opposite of all this, contradictions. A contradiction is a formula or assertion that is false in every possible interpretation. Or in other words, a contradiction is a statement which has the truth value false irrespective of the truth values of its component statements. For example, taking the case of the statement P and negation of P. This proposition could be understood by mapping the truth table of its constituents and then applying the AND operation. P and negation of P shows all values as false and thus we can say that P and negation of P is a contradiction. Let us consider another example. For any two propositions P and Q, P implies Q is equivalent to whole negation of Q implies negation of P. This could be validated by drawing a truth table. Let us first flip the values of both P and Q to get the negation of each of them. Now we fill in the P implies Q values and the negation of Q implies negation of P by using the same principle. Yes, they are the same, and that is because they are contrapositives of each other. But let's just forget that for a minute and focus on the steps. Now by flipping the value of negation of Q implies negation of P, we obtain the whole negation truth values. Now if we compare P implies Q values with the whole negation of Q implies negation of P, we can see that none of the columns match and thus the final values are all false. If all values of any proposition results in false, it has to be a contradiction. If we have two propositions P and Q such that P is equal to Q, then we say that P and Q always have the same truth values and P implies negation of Q is a contradiction. We saw in the previous slides how P implies Q equivalent to negation of Q implies negation of P is a tautology, and also how the negation of P implies Q equivalent to negation of Q implies negation of P is a contradiction. If we compare these two statements, we can understand the relation between a contradiction and a tautology. The general principle is that negation of any tautology is a contradiction and vice versa. Propositional logic has its own set of rules which help in logical calculations. We will use propositions P, Q, and R to discuss these laws. Imagine you want to calculate the disjunction of P, Q, and R. The associativity states that we could perform P or Q first and then perform OR with the R, or we could calculate Q or R first and then with P. Both would be the same. The same law also holds for conjunctions. The commutativity represents the symmetry between both and or connectives. In other words, P or Q equals to Q or P. Also, P and Q equals to Q and P. The distributive law is defined from the algebraic law that multiplication distributes over addition. Similar to that, we can say that the AND operator here gets distributed over the OR operator and vice versa. Now, we consider two more laws. Let us consider two statements. Statement T representing tautology and statement F representing contradiction. This means T is always true and F is always false. The identity law of propositional logic states that for any proposition P, P and T would always be the value of P itself, and P or F would also result in the same P. In simple language, conjunction with tautology or disjunction with contradiction both would result in the original value. The complement law states that P and negation of P equals to F, which means it will always be a contradiction. On the other hand, P or negation P equals to T, which means it will always be a tautology. All these laws would help you solve propositional logic problems, and they are generally used to convert complex logic into simpler forms. With that, I conclude propositional logic. In the next chapter, we will dive deep into predicate logic and understand how English statements could be quantified into logic. Thank you for watching this lecture.